Hi, here's the 2020 calculus exam. We're going to do the achieved and merit questions only. So let's get into it. Key word here is the word gradient. When you see the word gradient, that means you're going to have to differentiate. So we're going to differentiate, whoops, what's happened here? We're going to differentiate this expression. Before we differentiate it, I'm going to expand it. So this will equal 5x cubed plus 10x. Differentiate it, so I'm going to change color. So we want f dash x, multiply by the power, reduce the power by 1. At the point x equals 2, we're going to put 2 into the fx equation. So that's going to give us 15 times 2 squared plus 10, and that's 60, which equals 70. Here's your first achieved question. The next one, we see here we've got a word here that says gradient. Gradient means you're going to have to differentiate. So I'm going to do that first, even before I read the rest of the question. So y dash equals negative 2x minus 3. Find the x-coordinate of the gradient function. Find the x-coordinate where the gradient of the function is horizontal. So if we have an evident negative x squared and we want the gradient to be horizontal, that means the gradient must be 0. So I'd put 0 instead of y dash, and I would solve for the 2x. So bring the 3 to the other side, change sign, and divide by negative 2. So x equals 3 over negative 2. Here's your answer, which is the same as negative 1.5. Hope that's all good. The next one, find the gradients. This is for C, find the gradients. So again, and we've got the word gradient. We've actually got a little s there, so there could be two answers. So be careful where this here crosses the x-axis. Now, if you think of a curve crossing the x-axis, it could cross in two places. So you're going to have two gradients. One would be a negative one, and one would be a positive one. So we're going to look for those two gradients. So first thing we're going to do is differentiate it. So differentiate, multiply by the power. Now 2 times 2 is 4x, and it's all over 5. And x differentiated is 1. Now we've got to find the gradient at those 2 points. Now we have no x values here. But we know that the y value is 0 because it's 0 high. So let's go to our original function here and make 0 equals 2x squared over 5 plus x. And if we can find what this is, then we can find where it crosses the axis. This 5 is a problem. I'll multiply everything by 5. So I've multiplied each term by 5. The left 0 times 5 is 5. Now I can factorize. Oops, it doesn't factorize with 2. It factorizes the x, 2x plus 5. So it crosses at when x equals 0 and also when x equals negative 5 over 2. So we can then put those into the formula. So when x equals 0, we have got 4 times 0 over 5 plus 1. So the gradient is 1. So when x equals 0, gradient is 1. And then we're going to do when x equals negative 5 over 2. So we put that into there. So we go 4 times negative 5 over 2 plus 1. And then find that when you multiply it out equals negative 1. So there are two gradients. This one has a gradient of 1. The other one has a gradient of negative 1. And we're done. That will give you merit. Find the equation where the tangent to the curve is. Now I know the tangent is y equals mx plus c. And so m is the gradient, which means I have to differentiate it. So I'm going to go ahead and I'm going to differentiate this straight off. So y dash equals multiply by the power, reduce the power by 1, multiply by the power, reduce the power by 1. The number disappears. So we've got that. We have to find the equation of the tangent. The x-coordinate is 2, so let's put 2 into there. 3 times 2 squared plus 6 times 2 minus 5. That equals 12 plus 12 minus 5. 24 minus 5 is 19, isn't it? So that's the equation y equals 19x plus c. Now I've got an x coordinate, but I haven't got a y coordinate. So let's use the x coordinate in here to find out what the y one is. So I'm going to go 2 cubed plus 3 times 2 squared minus 5 times 2 plus 1. So that gives me 8, and 4 times 3 is 12, 20, minus 10 is 10, plus 1 is 11. So we have the point 2, 11 as my coordinates, so I can now put this in the equation for the tangent. 11 is your y value, and I've got equals 19 times 2 plus c, that's 38. So we subtract 11 minus 38 to give us our c value, and our c value is negative 27. Hope you can see that. It's a bit weak for this time of night. So we've got y equals 19x minus 27. Whoops, it should be negative 27.